Yo, 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 YouTube, what's up? What's up? What's up? What's up? What is up? This is Greg from Greg's Tutoring NYC. Hopefully everybody's doing okay. Just trying to get this going on my phone to make sure we're live. Please like and subscribe. We're on about part number, I think number 7 of this series. So we're doing grade 7 hardest math problems. Gonna do this maybe about 45 minutes today. I think some of the examples at the end of this are a little easier than the others were. Doesn't mean they don't have gotchas involved, but let's see how we go. I'm short on time, and my head is killing me, and yada yada. So let's see where we can go on some of this. My screen seems to be out of focus. Though it's coming in clear on my phone. That's pretty odd. Okay, that's YouTube doing stuff with density information, I guess. All right, so we're doing our hottest math problems. We're on part 7, and let's just jump into this. And if you guys have any questions, you can always email me at GregsTutoringNYC@gmail.com. Okay, let me get rid of this here. There we go. There's our first set of problems. So let me make sure my pen is going. If you're catching this on the replay, you can pause the video and then see if my answer matches yours. I like to do further exploration on the problems too, because as much as this is about solving a specific problem, in this case number 36, at the end of the day, this is about your math proficiency, your math mastery. It's about solving problems in the wild, right? So that's what we really want to end up kind of be shooting for here. So Jeanette purchased a contest ticket on a website. Cool, no big deal there. The original price of the ticket was $75. Okay, so far we know she bought a ticket for $75. She used a coupon code to receive a 20% discount. So if you had watched some of my other streams, especially on the grade 7, you should note that this is, we can take the price, figure out what 20% was, and subtract it from the 75, if that's what the eventual question is. We could also say that if it was a 20% discount, it's 80% of the price. Okay, so I covered this in depth, probably in part 2 or 3. This has come up in every part, but as a kind of quick sidebar, percents is a big part of this test. A lot of grade 7, even though it also introduces algebra and so on, is arithmetic based, right? All of your elementary school stuff is really based on arithmetic. That's a super strong aspect of everything that's going to be going on. So, and percents is part of that. Okay, so that's something you need to have figure it out. And if you look at the problems here that are being termed the hardest math problems, the ones that kids are getting wrong the most involve percents. So percent is a concept and a topic and an actual examples like this that you guys should really beat the daylights out of to make sure you're proficient in it, because it comes up a lot, and if nothing else, you're being graded on it. Okay. It also comes up in your real life. Everything we buy might have a discount, something added to it. You're just trying to figure out something, even if you're figuring out how to paint the room or something. You're always just trying to figure out an estimate, how to go to a restaurant, split a bill. If you're paying New York City tax, which is about 10%, how to figure that out. So percents is in our daily lives, right? You may also have a part-time job and you want to start saving like 15% of everything you make or whatever. So this is not just some odd concept that you're never going to use in your life. I agree. There's certain mathematical things that many of you are never going to use in your life. But percents comes up always. Plus, you're being tested on it. Okay. So she used the coupon code to receive a 20% discount. So it's the same as saying she paid 80% of 70, right? Okay, just give me 1 second. I want to make sure we're still live. Okay, we have somebody in the lobby. Greetings. Let me go back to the examples though. So 80% of 70, right? So we're up to here at this point. And the website applied a 10% service fee to the discounted price. So we're going to get 80%. Sorry, it's actually 75. That's my dyslexia kicking in. Let me actually change that to make sure we're looking at the right number. You guys need to spot me. So this is now the discounted price. I'm going to underline that in green or purple or whatever color comes up here. This green underline is the discounted price. And then the website's going to apply a 10% service fee. So we can multiply that whole thing by 10% and then add it back into itself. Okay. I also talked about this in, I think, the third or fourth live stream on this grade 7, which is this is the same as 110%. Right? It's the full price, which is 100%, plus 10 more. So that's what we're going to apply is 110% onto the discount. Right? So there's a little confusing wording here because it's saying it's going to apply a 10% service fee to the discounted price. So there's a discounted price, and then they're going to charge you something on top of that. Okay? So it sounds like it's being discounted further, but it's actually adding to your bill. So if the discounted price was $100, they're going to charge $10 on top of it. They're not going to discount $10 more. They're going to give you a fee, a charge, right? That's what it says, a fee. It doesn't say a second discount. This is one of the issues the kids have with it. This is probably a question that almost the largest number of kids got wrong, is this question right here. Okay, so the 80%, we're just going to start mapping now. Okay, 80% is 80 over 100. Of means multiplication of 75. Okay, we don't really need this parenthesis anymore, but we can keep it. And then it's times 110%. So that's just 110% means over 100. So it's just 110 over 100. Okay, and I'm just going to put a little arrow here because this is the same as 1.1. Okay, so we don't kind of know where the problem's going yet. So Jeanette's ticket was less than the original price by what percent? Okay, so that's what we're trying to shoot for. So we're trying to look for an answer in percents. So this problem is different than many of the other problems I covered so far in this whole series because it's a multi-step word problem. Okay, once we figure out the answer to this thing right here, we have to do something further with it. Okay, so we just can't stop there. So another issue you guys have is that once you see something like this last whole expression in green that I've written, many of you are just going to start multiplying that out. You're going to do 80 times 75 times 100 and then divide it by the whatever. But we can also note the certain things that are going on here. I'm just going to take a sidebar for a second in a different colored thing here. If I have A over B times C, right? Well, any number is itself over 1, right? So in this case, we're talking about C. C is itself over 1. So A over B times C is the same as A times C over B. Okay? And that means if we see something we can cancel between B versus A or B versus C, we can do both of those. So we're allowed to do the conversion, the simplification, across the two fractions. So why am I pointing that out? Because 75 over 100 is the same as 3 over 4. So we no longer need to do 75 times 80. Okay, we can do it. We can do it. It'll still get the right answer, but we don't need to. And then 4 goes into 80 20 times. So we took kind of that ugly fraction multiplication, and it just reduces to 20 times 3, which is 60, right? So we get 60 times 1.1. And we can certainly set that up here, 1.1 times 60. And end up getting 66. Because when you get 60 plus 10% of 60 is 6, so we're going to get 66. Okay, if you notice, none of the answers over here looks anything like or near 66. So what do we need to do? So I would suggest everybody watching this right now, go back and reread the question. Let me just make sure we're live while we're doing that. All right, I see some more people in the lobby. Greetings. Anybody has any questions about what I'm covering? That's cool. By the way, if you guys have questions about things I'm not covering, you can put them in the chat. And I might avoid them until the very end, but certainly put them out there. And if somebody's very shy, you can always email me your questions. Okay, this is about trying to help you guys. This is all free. So I'd wish you'd be my students, my paying students, but right now this session is free. I love to get back. So it's asking, if we look at this last, Jeanette's ticket was less than the original price by what percent? So what we need to do is the original minus this new thing over the original price. Okay, so the original minus n is 75. Minus the 66. And that gives us 9, if I've got that right. Okay, so that's going to give us 9 over 75. So as you see, this is a meandering, wandering problem. Whoops, I said 75. So this is where your numeracy can kick in. You can do 75 into 9 if you want. So let me make sure this is coming to your guys' screen. Give me 1 second here. Yeah, let me lower that down slightly, so I can actually do that division there. Okay, there we go. We can do 75 into 9. Okay, 75 into 9, you can't do it. 75 into 90, we bring the point up, we go once, right? And we have 15 left over. And that's 2. Okay, so that ends up 0.12 is 12 hundredths, and that's what this means. So the answer turns out to be C. So it's important to get the 66, figure out the 9 from the original price, and then apply it to this here. And by the way, on that same note, we actually didn't need to do this division per se. Because if we have 9 over 75, and again, this is where your numeracy and so on comes into play. Do that 9 a little better. You can convert this to decimal a lot quicker, because if this is 75, we can break it into 25ths, right? So this would actually be 3 25ths. We divide the numerator by 3 and the denominator by 3. And if we multiply the numerator and denominator by 4, we get 12 over 100. Which again is 12%. Now this here looks like it's extra steps, and it is an extra step, but it's trivial to do. And as much as you should solve the problems by writing them down, this purple thing right here is something you can do in your head. Once you can see that 9 75ths would be 3 25ths, you can multiply the numerator and denominator and just get to 12 100ths. Anyway, it's another way to double check it, even if you write it out on paper. All right? So that's kind of a coolish example in a way. I think there's another one at the bottom of this page, which is also a percent problem. So the amount of money in a bank increased by 21% over the last year. So at an increase in 21.5%. Okay. So, you know, I've been talking about this would therefore be 121.5% altogether. Okay, so even as I'm writing this, I'm noticing that really nothing in the answer choices deals with that. So let's see what the rest of the words say to us. If the amount of money at the beginning of the year is represented by N, which expression represents the money in the bank? So if we start with N, okay, we're really looking at 121.5% N. Okay, but no answer matches that. But if we look at this, because I added the 100, this is really 100% N. Plus the 21.5% N. Right? Does that make sense? Go back and reread it. The amount of money in the bank increased, so that's the money in the bank. It increased by 21.5%. If the amount of money started out as N, just N. Which expression? So 100% means 100 over 100. Percent means 100. Divided by 100. Okay. So what we're trying to do at this point is find A, B, C, D to match whatever that is. So then this is 21.5 over 100, because again, that's what percent means. Times N again. Now 100 over 100 cancels out. So this first term is just N. And 21.5 over 100, I don't see that there either, but I notice there's decimal forms of numbers. So let's convert this here into a decimal. So it's divided by 100. We're going to move the decimal point over to the left twice. 0.215. So we have N plus 0.215N, which is A. Right? So if we can notice the pattern that's going on with some of these problems too is they're not always asking for the exact answer. They're just trying to look for the right expression that matches it. So really this is the so-called top level form of it, and or this one was as well. So what we need to try to do is find an answer choice that matches either this or this. Okay, so that can be a pain in the neck at times, and what you have to kind of do is understand your identities and all your mathematical properties, and sometimes even a formula. But also meant understanding what it meant to increase by 21.5%. All right, because that's kind of important as too. Because if you don't know what that concept is, none of the answers here are going to start making sense. All right, and it's important now that we can actually see the final answer was A. It's the whole thing. Let me change the color of this. It's the whole thing plus that 21.5% increase. Okay, now I'm talking before about the 125 over here. So this second term can just be 0.215 because the 100 part is the first term right here. Okay, so instead of saying 1.215 in, right? Because if we actually combine the two terms in choice number A, that's what we're going to get. We're going to get 1.215, which turns out to be this, and also that. So it can sometimes be nasty and tricky and whatnot, trying to yin yang some of these things back and forth together. So there's that. Let me just make sure we're live here. Which turns out to be this. Okay, yes we are. All right, so let's do a couple more problems. I'm going to go about maybe another 20 minutes here, maybe even less. Let's see. All right, so that's that. And some of these problems add topics that we haven't covered so far either. So remember, I'm Greg at GregsTutoringNYC. I tutor for a lot of specialized exams, especially for high school entry, like the SHSAT, the ISEE, the SSAT, the TJHSST, the Hunter College High School test, the Bergen County Academy test in New Jersey. Actually, I tutor tests for other exams for other states as well, like the Boston Exam School and the Chicago testing schools, and even in other countries like New South Wales. So, even though I live in New York City with online stuff and so on, it's not a big deal or a big problem. I also tutor homework help and so on and whatever as well. All right, this seems like it's never ending. Where's the first part of this? Okay, here we go. Come back. Whoops. Okay, it's not on the screen fully. Okay, here we go. Okay. Keo uses wire fencing from a border around a circular region in his backyard. If the radius of the circular region was 5 yards, what is the total length of the border? So this is a perimeter problem involving a circular region. So we can visualize it. It talks about a radius. So he uses a wire fence forming a border around a circular region in his backyard. So the backyard, we don't know the shape of it, but let's just say the whole backyard is a rectangle. That's a bad rectangle, but if the radius of the circular region was 5 yards, what is the total length of the border? So the border is going to be the actual line going around the circle. In other words, it's the circumference. So you guys should all know your formulas, that the circumference is 2 pi r. If you guys don't know that, you're going to have big problems, because this is something standard that you should have memorized a long time ago. Okay, so all we have to do is plug in the 5 there, and we're going to get 10 pi. Okay, and this is in yards, because that's what originally started. And there's no unit conversion involving here that we can see so far. So we have 10 pi. Okay, I don't know what to do from that point, so I'm going to look at the answers, because I don't know what form it's looking for it in. So all the answers are whole numbers with a decimal. In fact, it tells us this need to be rounded to the nearest tenth. Okay, so most of you should know that pi is 3.14 at least. Okay, and 10 times that would give us 31.4. Okay, and it's not a case that the next digit here is going to round that up. In fact, it's a 1. Because there's other digits like 3.1415. So actually, it rounds to the 31.4. It doesn't go to the 31.5. And if you look at the choices, that's not even one of the choices possible. So that's not even an issue here. Some of you guys learned to use pi as 22 over 7. You should know both forms and use the one that it tells you to use. If it doesn't mention the 22 over 7, don't use it. Okay? And just like you should be memorizing the circumference equals 2 pi r, you should be memorizing a couple of the digits of pi. Okay? It's also on your calculators as well, but there's a lot of exams where you can't use calculators. So normally in a problem like this, it might give you some of the digits and say, here's what pi is equal to. In this test, it doesn't do that. So, but you should at least know it's equal to 3.14. So this one isn't too bad of a problem, but enough kids still get it wrong. Probably because they don't know pi, and probably because they don't know the circumference formula. And enough kids can't, so this is where concepts get important, that they don't know when it talks about the total length of the border. They don't really connect that up, that they're talking about the perimeter, which for circles is called the circumference. They can't connect those dots, so to speak. So that's why this is really about concepts and topics, not as much as it is about the low-level stuff of trying to solve these problems. All right, let's see if there's another problem. This page. Nope, so let's go to the next page. Okay, this one, just by seeing the answer choices without even reading the words and looking at these ABCD choices here, it involves a number line. I see some open holes here, right? It could be, you know, it's this right here. That's not filled in, so that means it doesn't include 5. So I'm already thinking this is an inequality, okay? And we talked about those on other streams. I'm just going to put NEQ. So that's my initial hunch. I don't know if it's true. So let's actually, so we're going to look at some of them. A goes from 5 to greater, not including 5. B is greater than 25, because 25 is not filled in, but everything else above it is. C goes from everything above 30, but not 30. And D goes from everything above 35, but not 35 itself. Okay, so from that extent, all the answers are simple, where whatever the thing is, it's either greater than 5, greater than 25, greater than 30, or greater than 35. So at least in terms of how this is graphed, it's simpler, because sometimes they might add a second graph here, like an extra dot or something else going that way. All right. So in this case, they're not doing that. So at least from that perspective, the example is not as complicated. That's not to say the example isn't complicated. I'm just saying from that context only. All right, so let's actually go read the words. Yolanda participated in a walkathon in which each kilometer raised $10. So that's a ratio. A kilometer maps into $10. Okay, I don't know if that's going to become important or not, but we're just putting down the math as we see it. Um, and that's often a safe bet on this kind of thing. Um, these are not super duper problems. By the way, I wanted to point out something earlier. Let me go back to that problem if I can find it real quick. This is going to take a minute. We're going to take a sidebar. Because I was talking earlier about how this is, even though there's algebra and so on this test, it's mainly arithmetic based. Let me find an example where we had the 75, the 80% times the 110 or whatever. Because I think it's a big point to make note of. Whoops, was that it? Nope, that wasn't it. Let me see here. One second, we just did it 2 seconds ago. Okay, this problem. So even though this, whoops, now I've gone too far past it. So even though this here, this got to be an involved problem, if you notice, the problem was written in such a way that this part I'm circling right now was just basic trivial math, where things just canceled out. And a lot of these kind of questions are oriented that way. That it's not really asking you to do double-digit multiplication and so on. It's trying to ask you, do you have mathematical proficiency enough to be able to see further past just the actual thing that's there? All right? So it's easy. The thing that's there, it's 80% of 75. But then the question is, what do you do with that? What do you do? Can you create a shortcut? Do you have enough mastery of the math to understand what the next step should be with that? All right? And if it means canceling stuff out so that your multiplication just goes down to 60, in seconds, 2 seconds, whereas the other choice is doing 80 times 75, maybe making an error, and then having to double check it. And that's not to say you don't need to double check this, you do, right? But if you notice, it just reduces down to simple math. So a lot of this stuff can look complicated on the surface. If you just back off for a second, you're like, oh, I can do this, right? Then again, that's your your mastery of the math. That if you can see that alternate or that other way to do something, why not do it that way? All right, so where are we here? Let me go back to the problem I moved off of. I think it's the next page. Let's see. Nope, we're not there yet. We're not Kansas anymore. Let's see. Is this it? Yeah, here we go. Okay, so Yolanda participated in a walkathon where she raised $10 each kilometer for charity. There's nothing else really going on there. Her goal was to raise more than 300 on Saturday and Sunday. Okay. So I don't know how to relate that to anything yet. She raised $50 on Saturday. So we can stop there and ask, you know, basically, how far did she walk? We don't know if that's where the problem's going to go here. But if she raised $50, okay, what's going to be there where X is? It will be 5 kilometers, right? Because this is times 5. That's times 5. So we don't know if that's what they're going to ask or not. But let's see where it's going. So that's the problem with some of this, where you can start second guessing stuff, but you might guess wrong. So part of this is going to be jumping at shadows, but it's still helpful because you're going to understand what the problem is asking you. Okay, and something that's true about this problem, which is why we want to stick with concepts and topics, is that the question, the last sentence here, which I'm just right at, that could change, but everything above it can stay the same. So that's why it's important to process these things in this way, so that you're understanding what's going on. Because you might get this right, and another tweak for the question, you might get wrong. So if you understand everything in the givens part, then you have a way to get through some of this. So which graph? So A, B, C, D are each a graph. A number line is a graph. Okay? Shows all the distances in kilometers that Yolanda could have walked on Sunday to reach her goal. What do they mean, all the distances? All the distances? Why all the distances? Right? Think about that. The reason it's all the distances is because it says more than 300. Okay? So what we need to do is, it turns out that this computation for X wasn't helpful. It was helpful to understand the problem, but it's not actually helpful to solve the question they're asking. So what we really need to do is take the 300, get rid of the 50, and we end up with 250. Okay? And it's the 250 that's important to us. So we don't really care that she went that. So what we're going to do is take the 250 and divide that by 10. And you all should know that's 25. Okay? So since she already raised 50 and she has to walk 25 more miles, right? That's what they're looking for. So this is not circled in here. The answer is B because it's more than 300. So if she walks exactly 25 miles, she'd make the 250. She already has the 50. So that would be exactly 300. She needs to do better than that. So it's going to be every number above 25, but not 25 itself. So therefore, the answer is B. All right. By the way, we could have written this algebraically as an equation, because basically what we have is $10 per kilometer plus the 50 that she already got. Okay, needs to be greater, more than, right? So that's what it says, the 300. So both ways of doing this are valid. Okay, everything above this line is still the same algebra, except I did it kind of logically. So this, we can do that same way. So we're going to subtract 50 for both sides. Okay, that goes away. This becomes 250. Divide both sides by 10. That cancels out. And that becomes 250 divided by 10 becomes 25. And the what with K is greater than 25, which still gives us the B. Okay? So there's a couple ways to do this. Depending on how you think, one way can be more efficient for you or than the other. If nothing else, you should probably do it both ways, just to double check it, make sure it's making sense that way. All right? Okay, 44 is kind of similar to the question we did maybe 4 or 5 questions ago. except it uses not. So don't let the not get you. So an item with an original price of P dollars, something's on price sale for P dollars. It's on sale at a 25% discount. So we have the similar thing. Are we going to do 100%? Are we going to take 25%, subtract it from the whole thing? Or are we going to do the 75% thing? Right? So which expression is not equivalent to the price of the item with the discount? Right? So let's look at the choices. So this says 1.0p. So that's the same as 1p or just p, right? So this says it's the price is going to be p, which is the full price, minus 25 hundredths of p, or a quarter of it, right? And that's what 25% is. So what we're really shooting for is 75% of the price. Which we know is equal to 75 over 100. Okay, so 1 minus 0.25 is going to give us 0.75, right? So A is equivalent, but they're saying not. So that means A is no good. Okay, B is actually exactly the same as A. It's a whole unit minus that gives us, so the parenthesized expression still gives us 0.75. Yeah, let me just fix that because it's not. Okay. So B is really the distributive property. And by the way, they remember that A times B plus C we all know it's AB plus AC, but we can also flip the order of these two. So this can also be written as B plus C times A. So that's all that's happening between A and B, because we can apply this to the P and this to the P, which will give us 1P minus 0.25P, right? And by the way, the parenthesis in A is unnecessary. It didn't need to be there because there's no other expression involved. Okay, so B is also 0.75P, which is a 25% discount. 1 minus 25%, 100% minus 25% is 75%. So B is 75%. So it's saying not. So B is not the answer choice. C is obviously what we've been talking about along. So C is not it either. So the only one that's not the correct equivalent is D. Okay, this one wasn't too bad, but that not kind of gets enough people. All right, let's see here. I'm going to do one or two more. Okay, this one's rather involved. Whoops. A student uses a solution that contains 16 grams of water to conduct an evaporation experiment. At the end of 1 hour, meaning the first hour, the amount of water in the solution has decreased by 3.5%. Decreased by 3.5%. At the end of 2 hours, the amount of water in the solution has decreased by another 4.25. So between the 1 hour and the 2 hour point, it's another 4.25%. Okay? So just looking at some of the answer choices, we see decimal numbers. So 3.5 is the same as 3.5. 3.5% is the same as 3.5 over 100. And that's going to be equal to, we're going to move the decimal place to the left twice. So we move it once, we get 0.35. We move it one more time, we get 0.035. Okay, so we can see that being used here. And the 4.25% is going to work the same way. We have 0.425. Sorry, just 0.425, not 0.25. That'll give us 2 points. Okay, we don't put percent after here. If I put percent here, that's not what it's talking about. Percent is already being used over here. So it's divided by 100. It's 4.25 divided by 100. So we get rid of that there, right? Because 4.25% is 425 tenths, hundreds, thousands, 10,000s. So 425 over 10,000. Okay? So which calculation can be used to determine the amount of water in grams remaining in the solution at the end of the second hour? So we have to compensate for what's happening the first hour, and in addition, what's going on with the second hour. Okay, so we had the discussion before about if there's like a 20% discount, we often make it 80%, right? But we just had the last question where that wasn't done. So we don't always know. We have to read the question in full to start deciding that. What's important is to just know the difference and when to use it. Okay, so let's kind of see what's going on here. So what we have to find out is with these 4 steps of each of these choices, which one of them makes sense. So if you remember, we started out with 16 grams, and at the end of the first hour, it's going to decrease by 35, the 0.35%. So what they're going to do on step number 1 is multiply the 16 times the 0.35. So that's going to be the decrease amount. I'm going to put GA here. Okay. So what they're going to do is step 2 is they're going to take the original amount and subtract the decrease. So this is now what's left. Okay. We started out with 16 grams. It decreased by 3.5%, and we end up with 15.44 grams. Okay. Step 3 here. So we already applied this bullet. Now we're going to go to this bullet here. So at the end of 2 hours, they decreased by another. So if you notice, this here is using 16, but this here is using the new value because that's the amount of water left. So that, in fact, makes sense. So it's going to decrease another amount of that. So it's going to be the 4.25 times that is equal to this. But if you notice, this number seems wrong. This is too small, right? The number should still be larger than that. I mean, sorry. Nope, that's correct. Take back what I just said. Okay, and then finally in the last step, it's going to remove this amount from what's left. So that's why this number and this number match up. Okay, there's a problem here. Is this number is the original amount. It's not what's left. So for that reason, A is no good. A doesn't work on this. Okay, so that's what we need to figure out on some of this. So step 1 looks like step 1 for A, so that's good. Step 2 looks like step 2 from A, so that's good. Okay, step 3 looks like step 3 from A, so that's good. And the difference now is they do that there. Okay, so they're going to take what was left from over here from the first hour and subtract the second hour off of it. So B is correct. Okay, let's try to bring C and D on the screen and just give them a quickie look. So the problem with C is that this is wrong. All right, as well as that. So therefore, this number and that number and that number and that number must all be wrong as well. And step D runs into the same problem. They didn't do the conversion of the 3.5% and the 4.25% correct. So that's wrong, and therefore everything else is wrong. All right, so we might do one more problem here. All right, so this whole grade 7 series I've been doing really hasn't had any probability questions, but probability ends up being part of the grade 7 stuff. So it probably means it's not tested often in the New York State test, or it means enough kids get them right. In fact, a lot of kids didn't get this question wrong. A lot of kids got it wrong, but this is one of the better, worse ones. Okay, so we're gonna look at the illustration. Just when there's a spinner involved, right? That arrow means you've seen this in board games. Somebody's gonna smack that with their finger, and it's gonna spin around. So this is basically dealing with probability. You just see that for starters. And I see 1, 2, 3, 4, and 5 in different assorted things here. And normally it's going to figure out the percentage of something versus another. So basically, I'm going to count the number of sections here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if I was just to ask myself a question about it, like 1 only appears one time. So the chance of spinning a 1 is 1/12. Right? Let's see. 2 appears 1, 2, 3, I think 3 times. So the chance of getting a 2 is 3/12, which would simplify down to a quarter. Okay, so I'm just doing hypotheticals here. I haven't finished reading the question yet. In fact, I haven't read the question at all. So this is my kind of default mode when I approach these. Again, look at the illustration, try to make sense of it. The arrow is currently between 2 and 3, but I don't think that ever matters because normally, basically, they're going to tell you somebody spins it and something's going to happen. So we don't know what's going to happen yet. This 12 is going to be important. So if you do count that, make sure that you're making sure you're not off, like you didn't count that was 11 or something. That's super duper important. So I don't know what else we can grok out of the illustration. So let's now go look at the words. A board game has a spinner divided into sections of equal size. So that's another thing too. Like the length of this versus the length of that, whether the same. So they're saying that each little slice here is basically the same area because that's part of it built from a circle. So each section is labeled with the numbers from 1 to 5. So we already noticed that too. But it's good to get confirmation because it's verifying that what you were trying to figure out just from the illustration alone is making sense. So now we come down to here. Which number is a reasonable estimate for the number? I'm going to get rid of the top so we can see the answer choices here. Reasonable estimate for the number of times the spinner will land on each section labeled 5 over the course of 150 spins. So how many 5s do we have? That's what it comes down to. We have 1 here. We have 2 there. We have a third one here. And if you count these wrong, you're screwed. So it turns out that's the same thing we got here, that 1 out of 4 times, um, there's a 25% chance of it doing that, right? So, so there's that. So the chance of getting a 5 is 1 out of 4. So if you spin, if you spin 4 times, you're probably going to get a 5. Is really what they're saying there. We don't know. That's experimental. The actual count, maybe you never hit a 5, right? So which number is a reasonable estimate? So they're not looking for an exact count. So make sure you notice this in a question of the number of times the spinner will land on a section over 150 spins. Okay. Well, 150 divided by 4, I can divide it by 2, I get 75. I can divide that by 2 again, and I get 37.5. Okay, since they wanted an estimate, then the answer is 40. All right. All right, guys, please like and subscribe. Hopefully you guys are enjoying this. Pass the word. Send me comments. Give me emails. Share this. Set your notifications so that you can be notified for additional ones of these. All right, guys. Hopefully you guys have a good day. Peace out. It's not letting me end. Peace.